Good morning, all of you. Myself, Dr. Sudharani. So, today we will discuss some topics about the cloud computing. Today, I am going to discuss about the theoretical part of the cloud computing. Okay. So, let us discuss the major cloud platforms. So many people, they may have the doubt, what are the common platforms or the major platforms of the cloud which we are using nowadays. So this is the, and how to use and what is the cost, how to use and what is the cost of the platforms which we are using nowadays. Okay. So here there are some major platforms which we are using today's. Major platforms are AWS, that is Amazon Web Service, Microsoft Azure, Google Cloud Platform. These are the three popular cloud services where we the people are using most probably. But the usage of these platforms used to be differ from one platform to another platform. So this is not known by many people. What is the major differences between all the cloud services? Today's in my lecture, I'm going to cover what are the major cloud platforms and what are their characteristics and how one platform is different from the another platform. First comes to the part of AWS. AWS stands for Amazon Web Service. So this Amazon Web Service. So these are some of the characteristics of AWS. And AWS is the EBS for block storage, Elastic Beanstalk for the block storage, and it goes with the Glaciers for actual data. That is low cost cloud storage service used for long-term data achieving and back. So why the people, most of the people go with the AWS means AWS is a low cost cloud compared with all the services. AWS is the low cost cloud storage service, and also it goes with the long-term data achieving and the backup. And next, coming to the database parts of the AWS, RDS. The AWS goes with the RDS, relational database systems, as well as a DynamoDB. So this DynamoDB, it comes under the NoSQL and Aurora, and it is a cloud native relational database. So AWS databases are the RDS as well as the Aurora. And what are the live examples of AWS? This AWS is best suitable for e-commerce applications. E-commerce app stores images in S3. So again, coming to the part of the S3, S3 is the object storage, which is used for the instant storage of data. And in my lectures, I even shown how to create the S3 and how to store the data. And AWS backends runs on EC2 or EKS. So for on every practical, we used to connect with the EC2 only. So EC2 is also object storage. We're used to connect for the instance storage. What is the instance storage like S3 or EC2? What is the instance storage means? When we are deleting, when we are terminating that objective, and the storage will also gets deleted. Orders processed using Lambda. Autoscaling handles peak traffic. Next, coming to the part of Microsoft Azure. Microsoft Azure was introduced in the year 2010 by Microsoft. Strong enterprise and hybrid cloud focus. Seamless integration with Windows, Active Directory, and Office. And what are the computer services? Azure Virtual Machines, Azure App Services. And coming to the part of Azure functions, like storage services, block storage. So coming to the block storage services, as I said, the storages are of three types. That is the block storage, file storage, disk storage, as well as the databases disk storage. And coming to the database and the analytics of Azure, Azure goes with the Azure SQL database, CosmoDB, and the Azure Synopsys Analytics. So live examples of Azure applications like bank uses on-premise service with Azure, web apps hosted on Azure App Service, transaction data stored in Azure SQL database. Next, third platform is Google Cloud Platform, GCP. Google Cloud Platform, built on Google's global infrastructure, strong focus on performance, data analytics, and AI. Compute services, compute engine, that is virtual machines, app engines, that is platform as a service, cloud functions, they are the serverless, and container and orchestration, Google Kubernetes engine, GKE, and coming to the data and AI services, BigQuery for large-scale analytics, Vertex AI for machine learning pipelines. Examples, research project analysis, terabyte scale data using BigQuery, machine learning models trained using Vertex AI, application deployed and GKE for scalability. Comparative analysis of AWS, Azure, and GCP. AWS, it is the largest service portfolio suitable for startups and scalable web applications, whereas Azure, best for enterprises and hybrid cloud deployments. Strong Microsoft ecosystem integration, GCP, best for data analytics, AI, and container-based systems. Example comparison, startup web apps, AWS, enterprise ERP system, Azure, data intensive research project, GCP. So these are some of characteristics of the major platforms of cloud platforms. Coming to the next part, here even I want to discuss with you related to some topic. Here we are even having some topics. Yeah. Coming to the part, what are the different databases in the cloud? Now I said that the databases in the cloud, we see that AWS is having RDS and DynamoDB, whereas Azure is having CosmoDB, and whereas GCP, Google Cloud is having BigQuery. So each platforms are using different databases. Now let us see what are the actual databases in the cloud and what are the difference between the databases. And first, let us go with the evaluation of cloud databases. So from on-premise RDBMS, monolithic shared architectures, Hadoop-based warehouse. This is the origin of the databases where we go with the on-premise RDBMS. And two, managed cloud database, serverless data warehouse, globally distributed multimodal, that is called as a DBs. This is the evaluation of database, and the evaluation of databases is very, very, very important to know how the globe and how the technology was totally changed by the evaluation of the database. Now, classification of cloud databases. See, here we can see the categories. Here we can see the categories of different databases. Category, example, and the workload. So first, manage relational. So that example is RDS, relational database system, and the workload is the OLTP. And next one is a serverless warehouse. And the example of database is BigQuery. And next one is the workload is the OLAP. And next category is globally distributed NoSQL. And the example is CosmoDB. And the workload is the real time. Amazon RDS, advanced view. So DS service overview, Amazon Web Services, Amazon Relational Database Services, RDS abstracts, provisioning, replication, backup, monitoring, and failover. These are some of the characteristics of Amazon RDS, Relational Database Systems. And RDS architecture internals. So here we use the components like EC2 based DB instance and EBS storage backend, multi-AZ synchronized replication, read replicas, asynchronous replication, technical insights, multi-AZ synchronized replication, strong consistency, read replicas, asynchronous eventual consistency, scaling in RDBS, vertical scaling, that is increase instance size, CPU RAM upgrade, horizontal scaling, read replicas, sharing application manage, limitations, true horizontal write scaling is limited compared to NoSQL systems. Next, BigQuery. BigQuery is used for distributed analytics engine. So BigQuery is a Google Cloud. In the Google Cloud, we go with the BigQuery. So BigQuery is the serverless distributed columnar analytics engine. BigQuery architecture internals, core technologies, Dremel execution engine, columnar storage, tree-based query execution, separation of compute and storage. BigQuery architecture internals, storage model, columnar-oriented storage, compression optimized, distributed file system backend, immutable data blocks, performance advantage, columnar storage reduces input or output for analytic queries, storage models, column-oriented storage, compression optimized, distributed file systems backend, immutable data blocks, and performance advantage, columnar storage reduces I/O for analytics queries. Coming to the part of CosmoDB, it's globally distributed system, and the overview of CosmoDB, Microsoft Azure, Azure CosmoDB, multimodal, multi-region, low latency database. And coming to the part of architecture, key concepts, partition keys, logical partitions, physical partitions, global replications, automatic shading across regions. Coming to the distributed architecture, key concept, partition keys, logical partitions, physical partitions, global replication, automatic shading across regions. Consistency model, that is called as CAP persistive. CosmoDB supports 5 levels, that is strong, bonded stainless, session, consistent prefix, eventual. And research focus, tunable consistent, trade-off between latency and correctness. Now coming to the part of comparative distributed system analysis. The first feature is ACID, feature RDS, BigQuery, CosmoDB. Here this table tells the differentiate between the different databases. ACID property. The ACID is RDBMS, it supports BigQuery, it supports only for the limited, and CosmoDB, it needs the configurable. And coming to the CAP, in RDBMS, it is okay, and here it is analytics, and here it is tunable. And scaling, in RDS, it is a limited horizontal. In BigQuery, it is a massive parallel. And CosmoDB, it is a global horizontal. And coming to the storage model, RDS go with the row-based storage, and BigQuery go with the column-based, and CosmoDB go with the document-based. And latency, RDS is ms, milliseconds, BigQuery it is a seconds, and CosmoDB it is the less than 10 milliseconds. Performance engineering comparisons, comparison PIs, RDS, optimized indexing, query tuning, instance sizing. BigQuery, it goes with the partitioned tables, clustering, query pruning. CosmoDB, partition key optimization, RES planning, region selection. So this is some of the points regarding the different databases between the different cloud platforms. Now let us go with the topic of cloud data warehousing. So up to now we've seen what are the different types of cloud databases. Now let us go and discuss the cloud database warehouse. What is the data warehousing? A data warehouse is a centralized repository designed for analytic processing, that is OLAP, and discussion supports. And the characteristics of the data warehousing, it is subject-oriented, integrated, time-variant, non-volatile. Unlike OLTP systems, data warehouses are optimized for complex queries over large datasets. Coming to the data warehouses, Redshift, Amazon Redshift, Amazon Web Service, that is AWS offers Amazon Redshift, a fully managed petabyte scale, massively parallel processing, that is MPP data warehouse. So Redshift is the Amazon cloud data warehouse. And coming to the architecture or Redshift, so here it is having the components of leader node, that is called as a query coordination, compute nodes, parallel execution, columnar storage, MPP architecture, and flow. First, it starts with the client, then it goes to the leader node, and from leader node, it goes to the compute node, and then to the distributed storage. Redshift storage model, it is a column-oriented storage. It goes with the data compression, block level storage, sort keys and distributed keys, and it is a columnar storage, improves scan speed for analytic queries. Query processing in Redshift, query passed at leader node, execution plane generated, distributed across compute nodes, results aggregated, parallelism models, distribution styles in Redshift, that is a key distribution, even distribution, all distribution. Now coming to the part of Snowflake. Architecture. This Snowflake architecture, it is a three-layer model. First one is a storage layer, next compute layer, cloud service layer, storage layer, cloud objective storage, that is S3 or Azure or GCS. Next, compute layer, that is a virtual warehouse. Cloud service layer, it is a metadata, query optimization, and authentication. Snowflake architecture, it is the micro partition, that is 16 MB, automatic clustering, immutable storage, time travel, and fail safe. Advantages, no manual index management required. Query execution model. This is the MPP based processing, cost based optimizer, results catching, automatic pruning, Snowflake pricing model. It is a storage, it's storage cost. So as I said, the pricing models are 3 types: compute, storage, and inbound or the outbound. So this is the storage model. Snowflake is a storage model. Pricing model is the storage cost. Means whatever the data you are storing, according to that you have to pay the money. Next, compute cost, and compute cost is per second. So means up to what time we are using the infrastructure of the cloud, we have to pay for that. That comes under the compute cost. Cloud service cost, the formula inside, see, total cost equal to compute usage plus storage plus data transfer. This is the 3 topics or 3 types of the cost. So some people, they may go with the compute cost, some may go with the storage, and some may go with the data transfer. But if you want the total, then the total cost is the compute cost plus storage cost plus data transfer cost. Advanced features. So this is the time travel, zero copy cloning, secure data sharing, multi-cloud deployment, semi-structured data. Redshift versus Snowflake. Here, these are the 2 data warehouses, Redshift and the Snowflake, and AWS is also go with the Redshift or the Snowflake, but these 2 are having some comparison. Now let us see what are the difference between the Redshift and the Snowflake. Coming to the feature of architecture, Redshift is the MPP cluster, Snowflake is the multi-layer cloud native. Next, storage and compute. Redshift is the historical couple, Snowflake is fully separated. Scaling, Redshift is cluster resizing, Snowflake is independent scaling. Maintenance, some tuning required, fully automated. And performance engineering comparison, Redshift, it is manually tuning by the keys and vacuum. Performance depends on schema design. And the Snowflake's automatic optimization, metadata, driven pruning, better workload isolation. Workload suitability, workload AWS native analytics, best choice is a Redshift. Multi-cloud enterprise, best choice is a Snowflake. Heavy workload isolation, Snowflake. Cost sensitive reserved usage, Redshift. Performance engineering comparisons, RDS optimized indexing, query tuning, instance sizing, BigQuery partitioned tables, clustering, query pruning, CosmoDB. So this is some of the information about the data warehouse in cloud platforms. Now, let's see, we discussed about the data, we discussed about the database, then we discussed about the data warehouse, and now let us discuss about the data lake architecture. What is data lake? So if you observe, we are coming step by step. First is the normal DBMS. Next, it is the RDBMS. Next, it is the data warehouse. Next, it is the data lake. So what is data lake? Centralized repository for storing structured, semi-structured, and unstructured data. Stores raw data in native format. Supports analytics, machine learning, and big data processing. Example, Netflix storing viewing activities for recommendation system. Data lake versus data warehouse. Already we seen what is a data warehouse, and now what is the difference between the data lake and the data warehouse. Data lakes, they are the raw data, schema on read. Whereas a data warehouse, it is a structured data, schema on write. Data lake supports AL or ML workloads. Example, Amazon S3, data lake integrates with analytic platforms. This is the data lake architecture, and we can see the data sources. We can see the data sources, IoT, apps, EBs, and the logs. So from any type of the data sources, from any sources like this, it is going to get the data. And next data sources, again, we are having different IoTs, apps, DBs, and logs. And storage layer, it is having S3, HDFS, Hadoops, and ADLS. These are the different types of data sources as well as the storage layers. So data lake architecture is nothing but from different data sources as well as the data layers. Data sources. So data sources are transactional databases like IoT devices, sensors, web and mobile applications, server logs, and clickstream data. Coming to the data ingestions models. So this is batch ingestion for periodic data uploads, real-time streaming injections, technologies, Apache Kafka, AWS Nesys, Apache Fluma. Data lake formation process. So here we can see identifying different data sources. Benefits of data lakes. It is scalable storage. Supports structured and unstructured data. Enable advanced analytics and AI cost-effective cloud storage. So we can see the data lake management, where we are having data governance, metadata management, data quality monitoring, data quality monitoring, performance optimization. Challenges: risk of data spam without governance, security and privacy concerns, metadata management complexity, data quality issues. Industry examples: Walmart processes massive retail transactions data. Uber analyzes ride data for pricing and routing. Spotify analysis streaming patterns for recommendations. You can see the professional architectural diagram of AWS, Azure, and GCP data lake. See, these are the different architectures of AWS data lake architecture, Azure data lake architecture, GCP data lake architecture. So data sources, coming to the part of AWS data lake architecture, we are having data sources, data ingestions, data processing. And in the processing, we are having Amazon EMR, Amazon S3. These are the security and governance. Coming to the AWS data lake architectures, we can see the data sources like databases, IoT devices, logs, webs and social platforms, and web format. And here coming to this part, data ingestion, Azure Data Factory, AWS Glues, AWS Lambda, AWS Glue catalog. Data processing, Amazon EMR, Amazon S3, security and governance, AWS IAM, AWS KMS. This is about the AWS data lake architecture. Coming to the part, Azure data lake architecture. Coming to the part of Azure data lake architecture. In the Azure data lake architecture, we are having data ingestion, data processing, and analytics and ML. For data ingestion, Azure Data Factory, Azure Stream Analysis. Data processing, Azure Databricks, HDLites, Azure Data Lake Storage. Next, data processing, Azure Databricks, HDLite. Analytics and ML, analytics and machine learning, that is Azure Machine Learning, Power BI, Azure Synopsys. And coming to the security and governance, it is the Azure Active Directory. And next one is a GCP. Next one is a GCP data lake architecture. So GCP data lake architecture, it is data sources. So data sources are again from Cloud SQL, IoT, files, and cloud data flow. Data ingestion, it is cloud or SAP, cloud data flow. Cloud, Google Cloud Storage, that is Cloud IAM, Cloud DLP. And analytics and ML, this is AI platform, Looker, data processing, security and governance, that is the Cloud DLP. So this is the architecture of different cloud platforms, that is AWS data lake architecture, Azure data lake architecture, and the GCP data lake architecture. These are the different architectures. These are the different architectures of different cloud platforms. I hope you all people understands my today's class. So today we discussed what are the topics we discussed means today we discussed purely about the different databases of the cloud platforms, like what are the different data types supports by different cloud platforms and what are the different databases are there. And then coming to the data warehouse like Redshift and FlowSnake architectures we discussed. And then we discussed about the data lake architectures. And again, in the data lake architectures also, we discussed about the AWS data lake architecture, Azure data lake architecture, and the GCP data lake architecture. So thank you all for listening, and we will meet with one more